Okay, let me go ahead and do this one now. The domain for this one would be 5x minus 1 cannot equal 0. X can be anything as long as this doesn't happen. We can't ever let 5x minus 1 equal 0 because that would make the denominator 0. So, we don't want to leave it like that. We want to rewrite that, use a little algebra, and say, well, that means that x cannot equal 1/5. Okay? Just solve that for x. So x can't be 1/5. This right here is the domain. Now remember, what we're also doing, though, is we're using the interval notation. So the interval notation would be, we're going from negative infinity to 1/5. Then we kind of jump over 1/5 and go to infinity. So we're going from negative infinity to infinity, except not 1/5. That's what we're leaving out. Okay, for this one, this is like another case here where we're saying, okay, 5x minus 1 has to be greater than or equal to 0. You can take the square root of 0, you can take the square root of these positive numbers, but if you let x be anything that makes this less than 0, then you're going to be taking the square root of a negative number, and that gets you into the imaginary numbers. So this one is 5x minus 1 has to be greater than or equal to 0. That means that x has to be greater than or equal to 1/5. And interval notation would be 1/5 to infinity. Like that. That's the interval notation. Okay. So we've got these two situations here. We've got the case where you have a variable in the denominator, and our concern there is that you never let the denominator be 0. And then we've got the even index radical, where you don't want to put yourself in a situation where you're trying to take an even root of a negative number, because that puts you into the non-real numbers. Okay. So these are the two. Then we have combinations. So let's look at a combination of the two. Let's suppose we have the square root of x minus 1, and down here x minus 3. And we want to find the domain of that one. So now we have a radical, even index radical, and a variable in the denominator. Okay, so here's what we've got. We've got two situations. One, x minus 1 has to be greater than or equal to 0, and x cannot be equal to, well, x minus 3 can't be equal to 0. So you have these two situations. You can't let x minus 1 be great, or x minus 1 has to be greater than or equal to 0, and x minus 3 can't be equal to 0. So you put these together. You have x greater than or equal to 1. Whoops, x greater than or equal to 1, and x cannot equal 3. So you could write that in interval notation. You could write that as 1 all the way to 3, and you kind of jump over 3 and go to infinity. And that would be the domain for that combination. Okay, now let's look at another combination. Let's suppose we've got 5 over the square root of 2x minus 1. Okay, so here we've got a radical, even index radical, and it's in the denominator. Now normally we would say, well, if we have an even index radical, we would say 2x minus 1 has to be greater than or equal to 0. But this is in the denominator. So it's going to be 2x minus 1 is strictly greater than 0. So that would mean that x has to be strictly greater than 1/2. See? So we would say 1/2 to infinity. Yeah, like that. So look, so look what we have. We have the straightforward variable in the denominator. a straightforward even index radical. And then we have a combination. I guess that's the most complicated one. And then we have another combination here where the even index radical is in the denominator. Yeah. So